Let's now introduce a new feature to our birthday book class. Let's say given the person's name, we want to get the birthday of that person. Let's first of all declare the header of the feature. Let's say a query, because we don't really intend to modify the state of the birthday book objects. We just want to inquire a particular person's birthday. So let's go under, do we have a query section here? No, we only got attributes and also we got commands. So why don't we create a new sections? Let's say right after the end of the attribute section, let's create a query, which will go before command. But the order doesn't really matter. So we can say feature over here, and then we say queries. And let's call the query get birthday, just to make it more informative. Let's say get birthday here, and then what kind of input should we take? Well, apparently given the person's name, we can return their birthday. So the input should be a name. Over here, the name should be of type string, right? Should be of the same type as the member of the names array. And now what should it return? So the return type, colon, should be of type, let's say, of course it should be birthday, right? It should be returning a corresponding member in the birthdays linked list or list. Let's put the birthday here. Now, as soon as I say this, I would like to remind you an issue that we talked about in the previous video, which is about void safety. Let me remind you this particular page over here that we described. Let me just remind you very quickly. Remember we said before, whenever you declare variables, the variable including attributes or parameters or the return value for your queries. So let's say, for example, when we say name is declared to be of type string, we are really saying the string value over here should always be attached. So which means your name cannot be storing a void value or null pointer. On the other hand, if you want to make some attribute value optional or variable value optional, you can say detachable, right? That's something we mentioned before as a concept, but we haven't really practiced that. So this video will be the chance to practice that. Okay, just remember the distinction there. However, on the other hand, in Java, we are not allowed to actually have this particular option over here. In Java, you can think about everything is detachable because Java compiler never checks to see whether your variable might be storing a null pointer. So that's why you got lots of null pointer exception at the runtime. On the other hand, IFO does provide you with this particular option here by default, which means the compiler is going to force you to initialize the variable. Otherwise, you wouldn't even your code wouldn't even compile, let alone executing at the runtime. Okay, so let's go back to IFO Studio. Let's now try to do the following. Okay, let's just get comments first. Okay, you should really put the indentation right. So let's say given an existing. So it's really important for the name to be existing. And we're going to put a backroad around the parameter name. Given an existing name, returns the corresponding birthday. Okay, so that would be the comments. And then, so now because we say given an existing name, so we are suggesting we should really force certain constraint on the clients. So there should be some input constraint. So we should put a precondition over here. So the name should be existing. You can think about this is kind of symmetric to adding a birthday. So if you go back to the command that we did previously, you can see in order to add a new record into the birthday book, we say that it should be the case that the name does not exist. But now, in order to inquire about a particular record's birthday, of course, the name should exist. So that's why they are logical negation to each other. I'm just going to provide one version to you. You should really try to practice to see if you can come up with other versions using either universal or existential quantification. I'll leave that as an exercise to you. Okay, so what I would do here is to say require over here. So let's say existing name. So you can see very obviously, this is the opposite to the precondition for add. Okay, so how should we do it? Well, easy. Given that we already set the object comparison of names to be true, which we did in the previous video. So what we can say is, we can say name names array dot has name. Okay, very easy precondition. And also, it will be an exercise for you to really try to write a precondition violation test for this. We did some examples already, so I'm not going to repeat this. Okay, I'll leave that to you as an exercise. So that'll be the precondition. So now, what's gonna happen if I hit the compile button? So that's my question. Okay, since I'm asking you this question here, so it may not be so trivial. Okay, pause a little bit to think. It has to do with what I said over here in the iPad notes about when you declare a variable by default is going to be attached. So what does that mean? It has to be initialized. So now let's try to compile. If I hit a compile button here, so you can see we got a compilation error, which means there's no way for you to execute the code until you fix this compilation error. Let's read it together. Variable is not properly set. Variable result. If you recall in the previous video for the birthday book, in the constructor, when the constructor was simply just empty, we also got similar to compilation error to say variables not set, attributes, names, and birthdays. If you have doubts, please refer to the previous video. I'm just drawing some connection. So it's a similar issue over here. Let me explain again. So previously, when you declare names and birthdays over here, you don't see the keyword detachable over here. So that means the names and birthdays, they must be explicitly initialized. They should never store void values. Similarly, if you look at this particular get birthday over here, it's very similar. Let me remind you something that we talked about previously. Okay, let me just go to my iPad notes over here. Okay. Remember, for every query with a particular return type, we actually said implicitly you're using that return type. Let me show it to you. So let's say over here, get birthday over here is the query that we just declared, right? So that's the query we just declared. And the return type is simply just birthday. It is not detachable. So that means it should always be attached. Implicitly, the first line imaginary, right? So in the first line, we are declaring result of type birthday, and this is always attached, always. It can never be void. And then implicitly, the last line will be to return the result. Okay. So now you can think of right now having the empty implementation over here is as if we only declare this particular result variable without ever initializing it, and then we are already returning it. As a query result, which is not acceptable by the compiler, because unless you put a detachable over here, which we'll do as another version. But for the current version, it's simply there's no. So that means this particular attached birthday object result must be explicitly initialized. So that's something you want to keep in mind. Okay. So always remember, by default, when you declare a variable of certain type, reference type, it should be always attached by default. If you believe, according to your design judgment, that for this particular variable, maybe sometimes you should be able to store, let's say, void or null pointer, like a nickname, for example, the example we talked about before. In that case, you should say detachable. Okay. Hopefully the principle is obvious to you. Let's go back there to iPhone Studio. So now let me just say this. Because the return type birthday is attached, we must explicitly initialize the result. Okay, so now in order to just make the compiler happy, let me just do it right now. So I would say creates over here, let's say result is of type birthday over here. So now as soon as I say dot, it's going to show me the constructor for the make, right? So this corresponds to what I just said. So the result over here has been declared of type birthday. That's why when I say create result dot, it's going to give me the constructor for the birthday class specifically. Okay, just notice the change over there. Okay, so now result dot make, and then just anything. I just want the default value over here. So for now, I'm just going to say October 15, right? It's not really correct, but I'll just say it. Okay, October 15. That's one way to go. Or you can also say, for example, you can also say result is assigned to maybe birthdays the list at position 1. However, this could be dangerous because what if birthdays linked list is actually empty? So this could be just if you just want to make the compiler happy, you may do it, but you might easily run into the index out of bound violation error. So why don't we just keep this one here just by default? Okay, just to initialize the result, just to initialize it. Okay, so it's always not void. Now everything compiles. So now I want to show you a contrast right away. Okay, so we want to define another alternative version of the get birthday. Okay, so now I'm just going to copy the header over here, and then I'm just going to give you just copy and paste. And now what am I going to do? I'm going to give you a more tolerant version of the get birthday. So now rather than get birthday, by the way, so you can overloading, meaning that you cannot have it's not supporting iPhone, meaning that you cannot have two features of the same name, even though they may have different parameters. So unlike in Java or C, C Sharp, for example. So in iPhone, they do not support overloading for the features. Okay, just okay, for get birthday over here. So rather than saying get birthday, let's say get detachable birthday, just to make it more explicit to you. Detachable. Okay, get detachable birthday over here, and then I'm going to put the return value over here. Rather than simply attached, by default, I'm going to put almost like a Java corresponding return as detachable, which means it can be void. Okay, detachable over here. And then, so now do we need to have a precondition? Not really, because now we're saying that the return birthday might be void. Void simply means the name you have supply as the input simply does not exist. So we don't need to put a precondition here. You can think about this is the more demanding version from the clients, because you are requiring the clients to actually give you an existing name. Otherwise, they will you will have the precondition violation. On the other hand, for this one here, we will always return some value for the birthday. It's more like a total function in the case of mathematics, if that analogy makes sense to you. So now if that's detachable, which means the return value may be void. Okay, that's allowed. Okay, so now I'm going to modify the comments a little bit just to make it very obvious to you. So now let's say returns the corresponding birthday if the name exists. Otherwise, returns void, like a null. And then notice the following, right? In the in this more demanding version over here, where the return value is actually attached, we were forced to do some initialization. But now you can see the body of the implementation body for this particular more tolerant version with the detachable return type. The body is here is simply just empty. So would it compile? The answer is it will compile. So now the compiler can tell the difference, because the compiler sees that over here because you say detachable. So let me be more precise by going to the iPad. So let's see this this particular alternative version that's more tolerance. So it's also a query. So you can think about by declaring detachable over here, it's really saying detachable here. So implicitly, we are really declaring result, the reserved key, local variable, to be detachable over here. So that is to say result right now does not have to be explicitly initialized, because it can simply just be void because it's detachable. Okay, hopefully you can see the difference, right? By really just declaring birthday versus when you say detachable birthday, it makes a difference to the compiler. So for you as a designer, there's no right or wrong choice. It's just about what you're gonna need for your particular application. So I'll show you both versions, how to make them work. In terms of the difference for these two, it will be different from the supplier side, also from some clients who uses this particular query. We're gonna see that for the rest of this video. Let me go back to the iPhone Studio here. So now the next thing to do, given that we have already considered a precondition and that this query does not need a precondition, let's now also consider the postcondition, right? Remember I said before, we want to get used to the idea about you should really try to think about the design before you dive into the implementation. That's really the mindset you want to get adapted. Diving into the implementation may be convenient, but you might end up spending more time than if you can spend a little bit time in the beginning to think about the design. So that's really the idea you want to get trained for this course. Okay, so now for this particular one, how do we write a post condition? I'm going to do the post conditions for both versions at the same time, because conceptually they are really similar. Okay, so I'm going to declare ensure over here. Okay, and also I will do in short over here, so we can compare side by side these two queries. Let me switch to iPad first of all, and then to talk about the idea for the post condition over here. Okay. How do we think about the post condition for both cases? Just say if I have this particular call to the birthday, right? Remember that's the birthday we had previously. So we got a birthday with 3 records there, and we got Alan with September 14, we got Mark with March 31st, and we got Tom with July 2nd, right? So only 3 records. Let's say now we are calling get, and then we want to get Mark, okay? Basically, somehow the implementation, so when you think about the post condition, imagine what's going to be the output, really. The output is going to be some birthday. So you can imagine what this is going to return will be the birthday for Mark, which will be March 31st. So you can think about this is really the value of the result of the query, right? So we're going to make it general. What's really the relationship between the result and this is the parameter name, right? Remember, in the both features over here, this will be the parameter name and the parameter name over here. So now, in general, in order to draw a relation between the parameter input and also the return value, we want to see what's the relationship between name and also the result. What is that? Okay. So now let's see this particular example, and then you will see. So let's say the name is basically Mark. Somehow we can get into this particular position in the names array from the implementation. Somehow we'll worry about the precise steps in a moment. This is actually of index 2. So you can think about the index of, imagine that we got this particular function that's supported. We can implement it if necessary. So let me write it down here. So you can think about the index of if I say Mark over here, we know that it's going to return 2. So in order to find out the corresponding birthday for return value, so what we should do is we should really say whatever this return value is, go to that corresponding position, and then we'll find out that particular birthday, right? So what we can think about is this particular return value is simply just equal to the following. I'm using TellDev for object comparison. It would be the birthdays array. Sorry, the birthdays linked list over here. Birthdays, right? It's a linked list. Add the position over here. So what should be this position? It should be exactly this expression over here. We should put over here. Should be the birthday at the position that corresponds to the position of the name, which is over here. Okay, so that's something we would like to specify, and it will be conceptually the same for both versions of the get birthday. Okay, let's go back to iPhone Studio, and then let's see how we can implement this. So apparently, we might need an auxiliary query to help us writing the contracts, so which is normal. So don't be hesitant if you think that you may have the need to define some additional auxiliary queries in order to help you to make your contracts more convenient to write. That's absolutely fine. Okay, so let's go back to iPhone Studio here. Let's first of all define a auxiliary query, index of name, let's say. Okay, so now I can just have another feature section over here. So let's say feature, let's say auxiliary queries. Okay, auxiliary queries. Okay. Let me move to the middle over here. Let's finish this particular query before we get back to the post condition for get birthday. So let's call that index of name. And then it's going to be a name, of course. It's going to be of type string. And then it's going to return an integer. Okay, let's document it right away. Okay, we can say returns the index of name in the names array if it exists. Otherwise, we're going to return an invalid index. Remember, we assume that indices of array start with 1. So invalid index could be just 0. Otherwise, returns 0. Okay, so that's our index of name. Just make sure everything compiles. And now how can we program it? So we can just use a loop to actually do it. You can either use a from until loop, or you can use a cross loop. It's completely up to you. But let me show you maybe using a cross loop in combination with a loop counter, which we didn't see before. Okay, you can just be creative programmatically. So let me just declare some loop counter over here. Let's say local I and integer. Because we somehow need to keep track of where we are if we use a cross loop. And now let me say do, let's give some initial value for result. Just to say initially result will just be invalid index 0. If it never gets reassigned, you will just keep the value 0. Okay. And now let's use a cross loop. Okay. I simply want to change from S to is right away, and then I can use names array, and then everyone is a local name, right? Alternatively, you can get rid of the loop counter here, and then you can simply use the interval over here if you wish, but I'll leave that to you as an exercise over here. Okay, and now I want to say it's nothing to do with termination, because when you use a cross loop, it's guaranteed to terminate. What I want to do is I want to make sure I is actually properly updated for every iteration. So whenever I need I to reassign result, I have the correct result. I have the correct I. So let's say just be more explicit. I can say I initially will simply just be 1. Okay, so now assuming that names.lower is equal to 1, and that's a valid assumption. That's the common assumption we make. Okay, and then we can say every time at the end of the loop, you can say I is assigned to I plus 1. Okay, just to make sure when we use I to reassign result, I has the correct value. So when should we reassign? So we're gonna use a conditional. To write a conditional in ifil, you would say if space, it gives you the code skeleton. If it is the case that the local name that we have over here, the dummy variable, is simply object equal to the parameter name over here, in that case, we can simply reassign the result over here to be the current I. That's what we can do, right? It's a very simple loop. You might be wondering, so what about other syntax for if? If you want to have more else if, you simply do this. I'll just show you quickly. You can say else if, and then it will give you another branch. You can have as many else if you like, and then you can have else to end the if statements. Okay, that's something I want to mention quickly, but it's very straightforward. Okay, but for now we don't need the else part. We just need the if. Okay, so let's make sure everything compiles. So the idea would be initially result will just be invalid index over here. If it ever gets the chance to get reassigned to the I, then that's good. So result will be some valid index. Otherwise, if it never gets into this particular if branch over here, result will remain its value to be 0. In which case, that simply means the name does not exist. Okay, so this routine actually works. For now, I know it works. So, but for your case, if you're developing this particular auxiliary query for you, for test-driven developments, you should write a test case for that. But considering the length of the video, I'm going to omit this testing part. So, but it's still important for you to do. Okay, I'll leave that to you. Okay, using this particular query over here, we can now write very expressive contract right now, right? We already explained that this particular relation that we would like to specify, right? The birthday that's returned is exactly the birthday at position that corresponds to the position of the input name. That's something we'd like to specify. Let's see how we can do it. Okay. So now let's go to the more demanding version over here, because we know that it is not possible for the result to be void, right? Because the return type over here is simply just attached. Detachable is not an option here in this case. So we'll simply say correct result. Correct result, that's a tag. And now we want to say result is simply is equal to, okay, as we said before, it's going to be birthdays at position. So what should be the position of that? Pause the video and tell me what that expression is before you see my answer. Assuming they have thought about it, so this should be the answer. You should say index of name and then the name. Okay, so now hopefully that makes sense to you. So let's compile. And also, again, for test-driven developments, later on, I wouldn't really show you this for post-condition test. We have seen 2 examples already in this tutorial series, but you should try to later write a post-condition violation test for this particular post-condition. You can try as an exercise. All right, so now let's go to write the post condition for this particular more tolerant version. The extra complication we have is there are two cases for the result value. Because the return type is simply detachable, that means the result can either be void or not void. In the case of not void, the post condition will be just like this. In the case of void, we had to write something else. Okay, so whenever you want to do some case analysis for the invariance, for precondition, for post condition, it's like for one case, you consider only one case at a time. So in that case, you want to use implication. So you may want to review the logical pattern for the birthday classes, class invariance. That's something we talked about previously. By using implication versus conjunction, you can review that part as well. But let me talk about different cases. Let's say case of non-void result. Okay, so there's a tag over here. And then we have another case, which we'll do in just a moment. Okay, so now how should we discuss this case? Well, you want to give the antecedent and give a consequence. Antecedent will be the result is simply not void. There are different ways you can write it. I'll show you both. You can either say result is not equal to void. Okay, and for the void, you can either be capital V or lower v. Doesn't matter. Okay, I'll just put lower v. If result is simply not equal to void, that implies exactly the case for the correct result. Yeah, exactly this case where the result is always not void. So I can simply copy this expression over here. It implies this. Okay, and then let me just make sure everything compiles. Okay, it doesn't compile. Let's see why. Birthdays over here. Sorry about that. So that means over here I forgot to do the result over here, right? I cannot just copy that expression, of course. It should be this. Implies the return value is simply object equal to the corresponding birthday, right? Just be careful when you do copy and paste. Okay, so this case is working now. I want to show you another way of writing this expression over here, and which will be more concise actually. So this one definitely works. I'll just put it into comments, Control K. Okay, what you can say instead, let me just copy that so you can see, you can keep both versions over here. Another way to write it would be, we want to say result is not equal to void. That means it is attached to some object value. So you can say attached. So this is something you want to get used to. Okay, whenever you can think about attached is a keyword in IFO. Okay, attached is used to create a Boolean expression like a check. So when you say attached result, it's as if you said result is not equal to void. It's actually attached to some objects, with some concrete address. Okay. And now, if I want to do the other case, I say case of void result over here. Okay, let me just also show you two versions over here. You can say when the result is actually equal to void. So that simply means over here, the name does not exist, right? That's the otherwise case, right? It returns void. That simply means the names array that has name is not the case, right? It does not have it. Of course, over here, you can also use either a for all or exists notation to write it. I'll leave that to you. Okay, let's make sure everything compile, and then I'll just show you one more version for this particular one. Okay, I'll put it into comments. So now for this part here, when you say result is equal to void, so what you can say is not attached, right? Not attached result, right? You can think about attached result is going to give you a Boolean if it is not void. But now it's saying it is void, so it should be the negation of that. Okay, hopefully that makes sense. Not attached result implies over here, not the case, names that has name. Yeah, this, I'm not sure if you prefer this version. You can see too many nots over here, but I think it's precise as long as you know what you're doing. Doesn't matter which version you're writing. Okay, so everything is working now. So what I would like to do now is to give the implementation for you, and then we'll do some test cases quickly. Okay, let's do one at a time. I think for both of them we can do very similar implementation, so that's not really rocket science. So, but I do want to show you two ways to write the implementation, and you can try. But to really try with this one here, I want to show you another common mistake as well. Okay, let's say this. Let me say I want to use a from until loop to implement this. I want to go across the name, go from index 1 until names.count, and then we want to find out which one to assign, right? So what I can do is I can do declare a local variable over here, and then I'll say integer I, which is integer I as a loop counter, okay? And then I will use a from until loop. And then I would say, let me just show you the whole routine over here so it's easier for you to see. I is assigned to 1, the lower index, until I larger than names.count. So we talked about such a pattern already in the previous video when we talk about arrays. I is assigned to I plus 1 to ensure termination, and now we can say very similar to index of names in some way, very similar. If names at position I is object equal to the name, the argument value over here, if that's the same, so that means result, which is of type birthday over here, right? It should be assigned to the corresponding position that the birthday stored in the corresponding position in the linked list of the birthday, right? The birthday over here at position I. Let's make sure everything compiles over here, okay? So now, let me ask you one question here. That's also a very common mistake made by your fellow students. You would think over here we are already guaranteed because the require tells us the name must exist in the names array. And then this particular loop will simply say eventually we should be able to have this particular branching condition to be true because name exists, guaranteed by the precondition. So we should be able to initialize the result to be whatever birthdays I would be. Eventually, it's guaranteed. So my question is, if I simply take this take out this particular initialization, which we said would be necessary from previous illustration, do you think if I click on the compile button, it will still compile? That's my question. Okay. Think about your answer, and then now let's see. If I say compile over here, it seems like it's not acceptable by the iFood compiler. It says that variable is not properly set, variable result. Okay. And of course, if you actually simply just click on the compilation error, it simply goes to the end of this particular get birthday routine. That simply means at the end of this particular routine, at the end of its implementation, it is possible that a result value for birthday which is attached might be void. And if you actually expand the error messages, it's saying exactly that. Variable is not properly set. Okay, that's exactly what it means. But now why? As I said before, even though this precondition over here guaranteeing that name should be existing, however, it's not part of. Okay, so now thinking this way, as far as the compiler is concerned, they try to analyze the structure of this particular loop over here. They see that because you will only try to reassign the result to be something that's not void over here. That's the line. However, that line is under some Boolean condition. However, the compiler cannot analyze whether a Boolean condition in general is true or false. Is an undecidable problem by the compiler. Okay? Undecidable simply means you cannot write a program to solve it. Okay, it's back to your theory of computation. I'm not gonna go into it too much detail. Okay, because this assignment over here is conditional, so the compiler will simply say, well, since it is conditional, it's possible that maybe result will never get assigned a value over here. So it is still possible result remains void at the end of this routine. Okay, so I'm just trying to tell you how the thinking logic is for the compiler. So just be careful. Okay, so now in order to fix this, okay, so we still have to keep this particular initialization over here just mandatory to get the compiler happy. You may think about why is a compiler so strict. I think we are trading errors at the compile time for runtime null pointer exception, really. So in iFood, it is guaranteed as long as your code is compiled at the compile time, it's guaranteed you wouldn't have any null pointer. Okay, that's about this particular implementation over here. And now I want to show you by contrast. Okay, let me still declare, let's go to the second version over here. And then I'll simply say local integer I of type integer. Sorry, variable I of type integer. Okay, and now we know that we don't need this particular initialization for this version here because that's detachable, right? So why don't I simply just copy the loop, okay, over here. And now, if I simply paste it over here, now, would it compile? We need explicit initialization. Would it compile? Let's try that. It does compile, okay, because it's detachable. Let me write the comments for you, and then I'll show you one more thing before we write the test. So here, let's say this. Okay, let me say this. Never occurs. Result will remain to store the default value void. This is acceptable because so why don't I do this one here? Okay, because for this one here, you can also use index of name, but I do want to keep this pattern over here for you, so you will remember, okay? But now let's say, rather than using this particular version here, select a block and Control K, put into comments. There might be a much easier implementation you can use, okay? In which case, we don't even need a local variable. Let me also comment it out, okay? What I can say is, I can say, result is simply assigned to index of name. So I can simply query what's the index of the name, and then I will simply say I don't need to write a test case for you. We can run this conceptually very quickly, right? This doesn't work because what if the name does not exist? Let's say the name does not exist. Let's say, for example, we have Alan, Mark, and Tom. Let's say we say Jim, okay? So now, in that case, if we pass Jim, index of name, and then Jim is going to return what value for the integer? It's going to return simply just 0, right? Because a result over here never gets reassigned, so it will just be 0. So that means the return value over here will just be 0 for Jim, and now you're saying birthdays at position 0. And now birthdays is a linked list whose indices always start with 1. But if you try to inquire about index 0, you're going to get index out of bound violation at the runtime. That's not what you want. So you want to make this conditional. Okay, hopefully you see my point, right? Of course, you can write a test case to actually test the violation if you wish, or just to see the stack trace accordingly. Okay, so what I would like to do now is to just make it a conditional. So I can say if, let's say over here, I can, of course, I can have a local variable here. Okay, let me change my mind. I'll simply just put local variable back over here, and then I can say I over here is simply assigned to the index of name over here. Okay, let's just say it's exactly that. Okay, now if I is a valid index for me to get indexed into the birthdays linked list, I can say I is larger than 0 or larger than equal to 1, okay, equivalently. If I is a valid index over here, and then we can do indexing into the linked list for the birthday book, for the birthdays. Okay, so now I can put I here. Okay, everything compiles. Okay, so these are the implementation options for you. So please make sure you understand the precondition, detachable, postcondition, and implementation, right? We talk about many details over here. Okay, but it's recorded, so you can rewatch it if you wish.